20D, sum number 2. A hollow sphere of internal and external diameters 4 and 8 centimeters respectively is melted into a cone whose diameter is given. Find the height of the cone. Well, volume of a hollow sphere is equal to volume of the cone as given in the question. Volume of hollow sphere is nothing but big volume minus small volume, that is 4/3 pi r1 cube minus r2 cube. The diameters are given, so we'll have to halve them to substitute the values of the radii. And volume of cone formula is 1/3 pi r square h. Pi gets cancelled, 3 gets cancelled, 4 stays. Substitute the values. Radius is given for the cone's base as well, only the height is missing. Solving further, we get the value of height, which is 14 centimeters. Now, the fourth question. The total volume of 3 identical cones is the same as that of a bigger cone. And bigger cone's height and diameter is given, and the smaller cone's radius is given. No, radius is asked and height is given. So, 3 times the volume of the smaller cone is equal to the volume of the big cone. Substitute the formula. 3 gets cancelled, pi gets cancelled. We know the height of the small cone. We don't know the radius of the small cone space. We know the radius of the big cone. By the way, diameter was given, so don't forget to halve it. Height of the big cone is also given. So the only thing missing is the radius of the small cone. So solve it and you get the answer as 3/1/3 centimeter. Next, cancel sum number 5, 6, 7. Let's do the 9th sum. The total area of solid metallic sphere is given. From that, we can find the radius. Then it is melted and recast into a cone, and the cone's radius and height is given. So, how many such cones can be produced? Pi's value is given, so we have to use this one. First of all, total surface area of a sphere is 4 pi r squared. TSA is given, so we can find the r, which is 10 centimeters. Now, number of cones is equal to the volume of the sphere upon volume of one cone. Volume of sphere formula and volume of one cone formula. Pi gets cancelled, 3 gets cancelled. The radius, we know, 10 centimeters. The radius of the cone and height is also given. Substitute the values and we get number of cones is 80. Now the 11th sum. A hollow sphere, internal and external diameter radii are given. It is melted and cones are produced. Find the number of cones, radius and height is given. So again, number of cones is equal to volume of the hollow sphere upon volume of one cone. Volume of hollow sphere, this is a formula. Volume of cone formula. 3 cancelled, pi cancelled. R1, R2 and R and H. All values are given in the question. Straightforward sum. Number of cones is 37. Now in 20E, cancel 1, 3, 4 and cancel 7. Yeah, 6 sum we are doing. 7th is cancelled. So we are doing sum number 10. Okay, 8 and 9 are for homework. It's 10, 6 and let's start with question number 2 of E exercise. So a buoy is made from a hemisphere and a cone. So it's shaped like this, which floats in water. The radius is given. It's 3.5 meters. Also, it's mentioned that the volume of the cone is 2/3 the volume of the hemisphere. So volume of the cone is 2/3 the volume of hemisphere. Formula. Radius is the same. That's good. 3 and 3 gets cancelled. Pi gets cancelled. And r squared and r square gets cancelled. This was an r cube, out of which r square is cancelled, so only one r remains. So this is how we can find the value of h, because we know the value of r. It comes out to be 14/3, 4.67 meters. Next, they want the total surface area of the buoy. That is the curved surface area of the cone and the curved surface area of the hemisphere. It's basically the area which would need to be painted if asked. Curved surface area for cone is pi r L and curved surface area of hemisphere is 2 pi r square. but we don't know the value of L, so we'll start with that. Use Pythagoras theorem to find the value of L. Don't use decimal values, always use fractions, because the decimal value was rounded off. This will be more accurate. So on solving, we get the value of L as 35/6 meters. So continuing with TSE of the boy, pi r I took common to simplify the calculation. L we know now, and R also is known. 7/2. Use fractions. Cut things as much as you can, take LCM and solve. In the end, you get this answer. Behind the answer is 1/3, but that's okay. Next, let's do the sixth sum. Hemisphere circumference is given and capacity, that is volume, is asked. Circumference is 2 pi r, so from that I can find the radius. Once I know the radius, I can directly substitute in this formula to get the volume of the hemisphere. What was challenging in this sum is the calculation. I suggest that you calculate on your own. Let's see if you are good at multiplication division. Spend some time on this. 10th sum. A cone and a hemisphere have the same base and the same height. Find the ratio between their volumes. Well, volume of cone upon volume of hemisphere, in the question it is in this order, so you have to stick to this order. Formula. Notice that radii are same, and even h is equal to r, so even this becomes r cube and this is r cube, so that gets cancelled, pi gets cancelled, 3 gets cancelled, so the only thing left is the denominator 2. So answer is 1:2.